I heard someone talking not too long ago, and they said something along the lines of, well, if you look at the fact that we have cannabinoid receptors in our brain, why else would we have those if it weren't for the fact that we were designed to consume cannabis? Something along those lines. I think the logic was something like that. How would you explain the prevalence or existence of receptors for these various types of molecules? I mean, we could use, is it cannabinoids? Is that how you say that correctly?
Yeah.
I'm not sure if I'm pronouncing it correctly. What would your response to that be? Or if you were sitting at a dinner table and someone brought that up, where would you take it?
I think it's not that complicated, actually. The fact is, so we have cannabinoid receptors in our brains, and we actually have cannabinoids in our brains. We have these peptides called, or these prostaglandin-like compounds called anandamines, and other types of things. These are effectively, they're our brain's own cannabinoids. Similarly, you see this with opiates. Opiate receptors in our brain bind to these opiate peptides like endorphin and dynorphin and those sorts of things. And they just happen to bind to the alkaloids from opium and have that effect. Similarly with serotonin receptors or dopamine receptors, all of these have their own endogenous, the term is endogenous ligands. And obviously for serotonin receptors, serotonin is the endogenous ligand. But interesting new findings, Tim, show formerly there was excitement, there still is excitement about endogenous DMT. And it's all related to the pineal gland and that sort of thing. Not so much. The current understanding is that the pineal is not so important. But DMT occurs in the brain, in certain parts of the brain, in rather high amounts in the frontal cortex. And this hasn't really been discussed or studied as much as it should. My friend John Chavez has gotten into this rather deeply. So DMT is an endogenous ligand, and DMT is a very simple molecule. It's only 2 steps from tryptophan, which is in everything, which is one reason why you find DMT in plants, animals, fungi. I sometimes in my lectures say nature is drenched in DMT. It's not uncommon at all. Oh, how did this come about? Well, it came about because these neurotransmitter-like compounds found in the brain are also found in plants and fungi, and they have similar evolutionary origins, basically. At some point, the fungi, the animals, and the plants split off from each other. There's this concept of the LUCA, the last universal common ancestor, which was, nobody knows what it was, but we know that it had to have existed. And probably it already had the genetic machinery to make these neurotransmitter-like compounds. And just like neurotransmitters in the brain, what they do is they facilitate signaling. They're signal transduction molecules, right? But plants and fungi and everything else use very similar molecules, sometimes the same molecules, for signal transduction processes in the ecosystem. Plants modulate their relationship with other organisms in the environment through signal transduction. And these messenger molecules, the plants make these sort of, they're called secondary compounds. And that implies that they're not important. They're absolutely important. But what they do, plants substitute biosynthesis for behavior, right? Plants modulate, optimize their relationship with everything in the environment because they can't respond, they can't run away, right? They're stuck in one place. So they do it through chemistry. And sometimes, this is like my usual rap, but sometimes the message is very simple. stay away. Get away from me. I'm poisonous. You don't want to muck with me, you know. Other times, the message is, come closer. Let's symbiose. Let's form relationships. All of this is mediated by these signal transduction processes, which is a special kind of signaling process in organisms that involves a receptor and a molecule that comes from somewhere outside or some other part of the brain and actually binds into that receptor. So it's a physical molecular interaction. That's what I mean by signal transduction, as opposed to, say, electrical nervous transmission, which also takes place. That's the It's not really a mystery. It's we evolved from the same origins. Not surprising that our brains have neurotransmitter-like compounds that resemble those we find in nature. And the interesting thing is something like psilocybin is a good example. Psilocybin has, phylogenetically, we're pretty sure that psilocybin's been around for at least 75 million years. The higher mushrooms, the basidiomycetes, are very old, long before there were animal nervous systems for them to interact with. But then animals did evolve, and turns out they have interesting effects with psilocybin. What was psilocybin doing in nature before then? Well, probably insects. It had to do with insects. It was either an attractant or a repellent. More likely an attractant.